Hi again. Alright, so let's check out horizontal asymptotes. So when you have p of x over q of x, where p and q are polynomial functions in standard form with no common factors other than 1, the graph will have at the most one horizontal asymptote. Look at this function here at 4x minus 12 over x minus 1. To get the horizontal asymptote, what you do is you look at the leading coefficients. Look at the leading coefficients, and what do I mean by this? I mean, look at the x, okay? The largest degree here is the x, thus the leading coefficients would be 4 and 1, and divide them. Okay, this is if they are the same. Okay, so we have 4 over 1. Then we have a horizontal asymptote here at y equals 4. Then we're also going to have that vertical asymptote at x equals 1. So I can go ahead and graph that. X equals 1 is here. And then y equals 4 there. Since this function is positive, it's going to start out positive, like that. And then the other side will be negative, just like that. Alright, look at this. And then this is true, this is only true if, the degrees, the highest degree, if the highest degrees are the same on top and bottom. In this case, we have 3x squared plus whatever, I don't care about that, I'm just looking at the highest degree, over x squared minus whatever, I don't care about that. So we have 3x squared over x squared, okay? So this is going to be 3 over 1, since these guys cross out. So I have a horizontal asymptote at y equals 3. And then I have my vertical asymptotes at, well, I'm going to factor out this bottom. This will be x minus 3 times x plus 3 at x equals 3, x equals negative 3. So let's go ahead and graph this. Since this is positive, the first bit will be positive, as in above the asymptote. Then it's going to follow that positive, negative, positive pattern. This bit will be negative, and then this bit will be positive. Okay, and then it's always good to just double check these. So when x is less than negative 3, is it positive or negative? When x is between negative 3 and positive 3, is it positive or negative? And then when x is greater than 3, is it positive or negative? Okay, so we can just plug these into the function here. When x is less than negative 3, say negative 4, this would be positive, this would be positive, so we're positive. When it's between negative 3 and 3, let's say 0, plug in 0, you have 0 equals 0 over 0 minus 9, that's negative. And then when it's greater than 3, say 4, this would be positive, and that would be positive. So we're good. We double checked it. Alright, next one. A hole is an omitted point in a graph. Alright, so let's look at this first one. We'll factor this. We have x plus 3 times x minus 3 over x minus 3. Okay, so these factors will cancel, and then we'll get a hole at x equals 3. So if you were to plug in 3, you wouldn't necessarily have that asymptote because our final graph doesn't have the asymptote. However, the graph before we canceled out our factors, you can't have that x equals 3 because you'd be divided by 0. Thus, we would have a hole. So this is really just a graph of x plus 3 like that. And then we have a hole at x equals 3. So right here, we have a hole. Okay, when you draw it, you just draw it with a hole, just like that. Let's look at the next one. X squared plus x minus 6 over x minus 2, so let's factor. We have x, this will be minus 2 plus 3. The x minus 2 factors will cancel out. We have a hole at x equals 2. So this is the graph of x plus 3. And then we have that hole at x equals 2. Just like that. Alright. Now, moving on. Okay, so let's look at this. So we have a fairly complicated graph. We want to identify the holes, asymptotes, and zeros, and then graph it. So let's focus on the asymptotes first. First thing I'll do is look at my horizontal asymptotes. I don't need to do any factoring for that. So observe that we have an x squared term over a negative 3x squared term. The degreeage is the same. So this is going to have an asymptote at x squared over negative 3x squared. Those cancel. So we have a horizontal asymptote at y equals negative 1/3. Okay? And I think I should clarify this. You can pass a horizontal asymptote. They're just used as guidelines, really. The graph has a tendency to follow those at limit behavior. So as x goes to negative infinity and x goes to positive infinity, it will follow whatever the horizontal asymptote is, as in it will get closer and closer to the asymptote. However, at smaller values, it won't exactly follow those. So it could possibly pass that. Okay, and there's a note in this packet earlier on that says that, yes, you can pass a horizontal asymptote. You just cannot pass those vertical asymptotes. So we have a horizontal asymptote at x equals negative 1/3. I've gone ahead and sketched that. Now let's go ahead and factor the top and the bottom. So let's factor. So I have x times x. This will be 3 and 4. On the bottom, I'm going to pull out this negative 3 I'll pull out. I have x squared plus 3 minus 4. Did I do that right? Yeah, I did that right. Okay, good. I'll factor that, so that's going to be negative 1, positive 4. Okay, so those will cancel. So I have a hole. I'm going to have a hole here at x equals negative 4. That's because I was able to cancel out those factors. I'll have a vertical asymptote at x equals 1. And those are going to be my defining characteristics of this graph. So I'll go ahead and plot the vertical asymptote. And my hole, I don't know where that's going to be yet. Okay, so we need to go ahead and graph this. So when x is less than 1, so when it's on this side of the asymptote, is its nature going to be positive or negative? Okay, so let's plug in 0 and see what happens. So I plug in 0, I'm going to plug it into this. 0 plus 3, that's positive. 0 minus 1 is negative, but it's being multiplied by a negative 3. So that's going to be positive. So this would be positive like this. Okay. And then when x is greater than 2, is it positive or negative? This would be positive. That's going to be 2 minus 1 is positive times a negative is negative, so that would be negative. Okay, there you go, just like that. Don't forget your hole. We have a hole at negative 4. So I have a hole in the graph right about there. Okay, so when you're thinking about this graph, it is continuous from negative infinity up to negative 4. We have a discontinuity. Then we have continuity from -4 up to our asymptote at x equals 1. And then we jump down, so we're discontinuous, and then we begin again at greater than x equals 1, and then we're continuous to positive infinity. So if you want to say your domain, the domain is going to be -infinity to -4, and then we can use this sign, it's called a union, -4 to 1, union 1 to infinity. And then our range here, our range, so we'd have to check to see the end behavior. Well, the end behavior, so again, this graph is going to follow the horizontal asymptote at the end behavior, meaning that it's not going to pass that horizontal asymptote of -1/3 when we're at negative infinity and positive infinity. And I can clearly see that when we're in the sort of inner trenches of this graph, that we're not passing that asymptote. So our range is going to be -infinity to -1/3, and then 1/3 to infinity. Ooh, that's a horrible infinity sign. Okay. Alright, next one. So let's go ahead and identify any horizontal asymptotes here. Okay, so I left this unsaid until now, but if your function has a power that is greater on the bottom, so this is a x3rd, it's on the bottom, it is always going to have a horizontal asymptote at the line y equals 0. Why? Because this will resemble the graph of 1 over x. Okay, it resembles that graph, and if you remember, that graph had a horizontal asymptote at y equals 0. So whenever you have a power that's greater on the bottom, so the 2x² is less than x³, it's going to have a horizontal asymptote at y equals 0. Let's factor this to be able to get our vertical asymptotes. So factoring, I have 2x plus 4 over, and pulling out an x² plus 7x plus 12, that's 4 and 3, so x plus 4 times x plus 3. These cancel, the x's cancel, so I have holes at x equals 0, there, and x equals -4. And then I have that vertical asymptote at x equals -3. So go ahead and plot those. Okay. And this is a positive graph, so it's going to look like this. Alright. And then again we have those holes at 0 and -4. That's right about there. So domain is going to be -infinity to -4, -4 to -3, -3 to 0, 0 to infinity. Our range is going to be -infinity to 0, 0 to positive infinity. Okay, last one. Slant or oblique asymptotes. With these, you want to divide. So let's go ahead and try that. So we're doing x² is divided by x minus 3. This is where you get to pull out your skills of polynomial division. X goes in x² x times. Multiply. Subtract it. 0. So 0 minus -3 is 3x. X goes into 3x 3 times. Okay, I'm not going to continue this, so this would just be, 3x minus 9, so that would be plus 9, so this would be plus 9 over x minus 3. I'm not going to continue, because I don't need to worry about this. I'm really just worried about this part. Okay. So when you have a quotient and the powers are not the same, so like x squared over x, and if it's larger on top, what you want to do is do polynomial division. This will give you your slant asymptotes. So we have an asymptote at x plus 3. Let's go ahead and graph that. And then let's try and figure out how this graph might look. Okay, do we have any other asymptotes here? I have an asymptote, a vertical one, at x equals 3. That's from here. Okay, there we go. So, our graph is either going to go from here and here, or it's going to look like this. To figure that out, what I want to do is, this will sort of be like my positive. So consider this area from the slant asymptote to the vertical one as like my positive. Consider this area as my negative. Consider this area as my positive, and this area as my negative. So I'm kind of splitting up the graph. This is kind of like, you know, like your axes are just kind of tilted it a little bit. Okay, so what I'm going to do is, when x is less than 3, are we positive or negative? And when x is greater than 3, are we positive or negative? So when x is less than 3, so let's look at 0. So plug in 0, I have 0 over negative 3. So that's negative. Okay, good. So then my graph will look sort of like this. And this should actually be getting closer and closer to the asymptote. Okay, and then when x is greater than 3, so plug in 4, 16 over 1, so it's positive, it's going to look like this. Okay. If you don't believe me, let me show you. Here's our graph. In this case, it looks like it went to 0. So I may have, yeah, if I had plugged in 0, let's see if you plug in 0, yeah, that was my bad. If you plug in 0 into this graph, so if you plug in 0 here, you should get the point 0, 0. So that was my bad. So it's just going to go here. Okay. And again, these are just rough sketches. And then, what else does it do? Looks like, yep. So we have that. We have that. X equals 3. We have a vertical asymptote. It's the green line, and y equals x plus 3. That's our slant asymptote. So there's our full graph. Alright, last one. Let's check out the last one here. So we're going to get our slant asymptotes and our vertical asymptotes. So notice how the leading coefficient, the power, is greater on the top. That means we're going to have a slant asymptote. So how to get it? I need to do some division. I'm going to do 2x squared minus 3x plus 1 divided by x minus 2. If you remember how to do synthetic division, please go ahead and do that. I do not remember how to do it, so I'm just going to use it my old-fashioned way. So x goes into 2x squared 2x times, multiply it, 2x squared minus 4x I'll subtract those. This will be 0 minus 3x minus 4x, so that's going to be x. Bring down the 1. X goes into x one time. Multiply x minus 2. Subtract 0, 1 minus is 3. X is not going to 3. I'm not worried about that. So your slant asymptote will be at 2x plus 1. So we have an asymptote at 2x plus 1. So go ahead and graph that. Okay, so that's our asymptote. I have a vertical asymptote at x. Let's see if I can factor this at all. Break it down. 2x negative 1 x minus 1. Okay, looks like it doesn't really factor down at all. So I'm going to have a vertical asymptote. Vertical asymptote at x equals 2. That's derived from my base there. X equals 2. Okay, and then to get my behavior, so it's either going to look like this, and this, or this, and this. So let's plug in some values. When x is less than 2, is it positive or negative? Think of this as your positive, this is your minus, this is your positive, this is your minus. And then when x is greater than 2, is it positive or negative? Alright, so when x is less than 2, so let's plug in 0. 0 minus 1, so negative 1 times negative 1 is a positive, over 0 minus 2, that's another negative, so that should be negative. When x is greater than 2, let's say 3, we have a positive times a positive over a positive. So that's going to be positive. So the graph should look like this. And again, you want to check to see if you're going to hit 0, 0 again. I'm not totally certain. Let's show it on the graphing calculator. Let's get rid of these. So here's our graph. Looks like we got to the point 0.50. Okay, and if you really wanted to figure out how to get that, you would plug in y equals 0 and then solve for x. But we're just sketching for now. And then here's my slant asymptote is this line, 2x plus 1. And then I have that vertical asymptote at x equals 2. Alright, there you have it. Enjoy. See you guys.